Alrighty, now let's go over these review problems that we had in class just to make sure if you have a question, let's make sure that we have it answered. So the first question is a reaction rate question. And the reaction rate questions are always the same. What is the rate law and determine the value of K, including the correct units. So the equation is written up here on the top. And so what the rate law will look like, it's going to say the rate equals K, and then times, and you're going to have the concentration of each one of the reactants. Now in equilibrium, the coefficient becomes the power, but that does not work that way with rate laws. So you're going to say it equals the concentration of the bromide ion to some power times the concentration of the bromate ion to another power, and then times the concentration of the hydrogen ion to, whatever power. And the powers are called orders. And remember, if it's a first order reaction, if it's first order, then whatever you do to the concentration, say if I multiply it by 2, the exact same thing happens to the rate. If I triple the concentration, it'll happen to the rate, because it's happening to the rate to a power of 1. If it's a second order reaction, then if I double the concentration, the rate's going to go up by a power of 2. If I triple the concentration, it goes up 3 to the squared. Okay, the rates can be, first order, second order, third order, or they can also be negative. If you have a negative order, for example, if the order equals -1, what that means is if I double the concentration, I actually make the reaction rate go slower. And also, if it's a 0 order, that means whatever I do to the concentration, absolutely nothing happens to the reaction rate. It doesn't have any effect of it. Okay, so our first job is to figure out what order this reaction is with respect to the bromide ion here. So I have 3 reactants, so I need to find trials. If I'm looking at the bromide ion, I need to find 2 experiments where the bromate ion and the hydrogen ion are the same. That means that any change in this reaction rate here is due to the change here. So I've got the first and second experiment. Now I'm going to list them as a ratio. I mean, I could actually just list them here as a ratio, but I like to list them with a bigger number on top so I can eyeball the answer. So I'll do it up here. When the concentration was 0.002, the rate is 5 times 10 to the -4th. Now when the concentration is 0.001, the rate is 2.5 times 10 to the -4th. It's always the ratio of the concentrations to some power equals the ratio of the reaction rates. So this is 2 to the m equals 2, so m equals 1. So that means this is a first order reaction with respect to the bromide ion. So I'll put a 1 right there. Now I'm going to do the same thing when I look at bromate. In order to find the order with respect to the bromate ion, I need to find 2 experiments where the bromide ion and the hydrogen ion don't change. So if I look at experiment 1 and 3, the bromide ion stays the same, and same with this guy. So I'm going to compare these rates with these concentrations. So when the rate was 0.0075, where when the concentration is at, the rate's 3.75 times 10 to the -4th. When the concentration is 0.005, the rate is 2.5 times 10 to the -4th to the power there. So when I do the math, 1.5 to the n equals 1.5. So n equals 1. So now this is first order. Okay, So it's first order with respect to the bromate ion. So I'm going to put a 1 up here. Okay, so now comes the tricky part. We need to find the order with respect to the hydrogen ion. So let's take a look here. That means I need to find 2 experiments where the bromide ion and the bromate ion are the same. So if I look at this, I see that the bromide ion is 0.001, 0.001, 0.001. That's great. But there's no experiment where the bromide ion is the same and the bromate. So what I'm going to have to do is I'm going to have to make it happen. So I'm going to do this to the third and the fourth experiments. The third and fourth experiments, these guys here are the same, so I'm good. So I need to make these guys equal. And I can do this because I know it's first order with respect to bromate, which means whatever I do to the concentration in this column, I'm going to do the identical thing to the reaction rate in that rate column. They're independent of each other. The bromide ion is first order. Okay, the bromate ion is first order. So if I were to double the bromide ion, I'd double the rate. I wouldn't touch anything else. So here I'm going to double the bromate ion, and I'm going to double the rate. So I'm going to take this 0.075 and multiply it by 2. That'll make these two guys equal. And because I did that, I'm going to take the rate and multiply it by 2. So that's going to become 7.5 times 10 to the negative fourth. Now I can easily find this order. So I'm comparing this and his rate to this concentration and his rate. So it's 0.2 is the concentration when the rate is 3 times 10 to the negative third. 0.1 is the concentration when the rate is 7.5 times 10 to the negative fourth. So 2 to the m equals 4, m equals 2. So I'll put a 2 up here for that. Now this is the answer to the question, what is the rate law? When they say, what's the rate law, they mean plug it in, figure out the orders. Okay, now, what's k? What's the value of k? To find the value of k, you're just going to plug your numbers into the rate law. And I have rate equals k times the bromide ion to the first power times the bromate to the third power times, well, that was a big lie. How about the bromate ion to the first power times the hydrogen ion to the second? Okay. Pick any one of these lines and plug in your number. But when you do so, you have to include the units. And the unit here for the rate is moles per liter per second. So let's include the units. The rate, 2.5 times 10 to the negative fourth moles per liter per second equals K times 0.001 moles per liter times 0.005 moles per liter times 0.1 moles per liter squared. When I solve that, I'm going to bring all of this stuff down here. So now I'm going to have 2.5 times 10 to the negative fourth moles per liter per second over all of this here. And I'll write the squared part out. Now look at your units. You have an m on top and an m on bottom. So you're left with 1 over m cubed times seconds. And when you do the math, you come up with 5,000. So that is K, including its units. All right, let's move on to the next one. Okay, the next one is a good old-fashioned KC calculation. You could do this one in your dreams here. It says initially, that's a key word. Initially, 3 moles of hydrogen and 5 moles of nitrogen are placed in a 1 liter flask. And then it says at equilibrium, that's another one, there is 1.5 moles of ammonia. Okay, so let's write our reaction. We have hydrogen and nitrogen makes 2 ammonias. Initially, that's this top line, and it's Kc, so it has to be in concentration, so we have moles per liter. So 3 moles per liter. It's in a 1 liter flask, so we're good with that. Okay, 5 for nitrogen, 0 here. Okay, then some of this stuff reacted. At equilibrium, you have 1.5 moles in 1 liter of ammonia. What do you have at equilibrium? Well, this is kind of what we did way at the beginning of this. I didn't have any ammonia. Now I've got some, so I've added 1.5 here. If I make 2 ammonias, I reacted 1 nitrogen. So that means I subtracted 0.75 here. And then if I used up 1 nitrogen, I used up 3 times as many hydrogens, so I'm going to subtract 2.25 there. So that gives me at equilibrium 0.75 moles per liter of hydrogen left over and 4.25 moles per liter of nitrogen. Now you're asked for Kc, so I'm going to write the expression. So you write it out, you have to write it out. And then plug and go. So Kc is going to equal 1.5 squared over 0.75 cubed times 4.25. So 1.5 squared divided by 0.75 cubed times 4.25. Kc equals 1.25. It's above 1, so it favors the products. Okay, next one. Initially, we have 3 moles of hydrogen, 3 moles of iodine in a 2 liter flask. Kp is 0.25, calculate the total pressure. Okay, so this is the Kp calculation. All right, same reaction. So we'll write the reaction. Well, it wasn't the same reaction. A much friendlier reaction. Okay, so there's our reaction. Now, it tells us we have 3 moles, and it's initially. So it's this top line. 3 moles of hydrogen, 3 moles of iodine in a 2 liter flask, and the temperature is 125. The first thing I'm going to do is I'm going to find the pressure, because this is a Kp calculation. I'm given Kp. So if I find the initial pressure, then I could do my table. When I come up with my answers down here, they're all 3 going to be pressures, and then when I'm asked for the total pressure, I'm just going to add those 3 numbers up. Okay, you could, having a wild streak, calculate, convert Kp to Kc and use molarity, and at the end change all the molarities into pressure, but that would be if you, I don't know, didn't have a life or something. So let's use the ideal gas law. We're looking for pressure. The volume is 2 liters. N is 3 moles. R is 0.0821. The temperature is in Kelvin is 398. Okay, plug it in. You're going to get the pressure equal to 49. That's pretty high. 49 atmospheres. So this is our starting pressure here. Our starting pressure here. Nothing here. X amount reacts, you make 2x here. So at equilibrium, I have 49 minus x, and 2x. So I'm going to write the Kp expression now. Kp is going to equal the pressure of Hi over the pressure of hydrogen times the pressure of iodine. Kp is equal to 0.25, so 0.25 equals 2x quantity squared over 49 minus x times 49 minus x. So now I'm going to take the square root of both sides, and I'm going to get 0.5 equals 2x over 49 minus x. And boy, don't you love your math teacher now? Okay, 24.5 minus 0.5x equals 2x. And then let's 24.5 is going to equal 2.5x. And if I divide that by 2.5, x equals 9.8. That's not the answer though, but that's x. So for the answer, I've got to come up here and plug it in. So if I have 2x, 2x is going to equal 19.6 atmospheres. That's going to be my pressure of HI. Okay, 49 minus x is going to give me 39.2 atmospheres here and 39.2 atmospheres here. So my answer is going to be 98 atmospheres. So my total pressure is 98 atmospheres. Okay. The last one here is the QC calculation. Okay, in a 1 liter flask you have hydrogen and iodine and HI, all of them together. Now, this should have actually given you the reaction so you know which way to write it, but we'll just go with this here. The question is it at equilibrium? And if not, what are the concentrations? All right, so they're saying that they gave us this bottom line. It's 1 mole, right? So it's 1 mole per liter. So we have 1.5 here, 2.5 here, and 3.5 here. To find whether something's at equilibrium, you determine QC, which is the reaction quotient. So I'm going to say it's QC equals HI squared over H2 times I2. Why do I write that out? Because I want the points. That's why. Okay, so that's going to equal 3.5 squared over 1.5 times 2.5. So that's not going to equal the equilibrium constant. That equals 3.26. Okay, so then you're going to compare that to the equilibrium constant. And Kc is 0.05. So you're going to write this. QC is greater than Kc. Because I know, and you can ask your Walmart greeter this, that 3.26 is much bigger than 0.05. That means it's going to shift to the left because we need that number to get down to where it's equal to 0.05. Those two things need to be written down. Okay, when it does shift to the left, that means we're going to have X amount. Well, actually, there we go. X amount is actually going to shift from the right-hand side to the left-hand side. So this is going to be minus 2x plus x plus x. So when we really establish equilibrium, it's going to be 1.5 plus x, 2.5 plus x, 3.5 minus 2x. So let's plug and go here. Let's get rid of this here and plug it in. 0.05 equals 3.5 minus 2x quantity squared over 1.5 plus x times 2.5 plus x. Okay, that's it. Your job is to solve for x. Okay? Now, the first person that sends me a message through Selly and tells me what x is automatically gets the first essay on tomorrow's test correct. 100%. That's it. That's an exciting challenge. Be the first person. Send me the answer to x. X equals this. Make sure you double check it to make sure it's correct. And then I will, of course, reward you with 100% on that first essay. That's a deal. All right. Thanks. Don't drink and drive.